Hello, my name is Alexa, and my altitude presentation is on obesity, diabetes, and heart disease. And we're going to be looking at moderation and mediation. To start off, this is what our variables represent, and just as a side note, if it has a C at the end of it, that means it was centered, and we center for moderation. For our moderation model, our monitor is going to be gender, and we're looking at how gender affects the direction and relationship between obesity and heart disease. For mediation, our mediator is diabetes, and we're looking at how obesity and diabetes interact to impact heart disease. And as Preacher and Hayes noted, this is a simple mediation because we only have one mediator, and each one of these precedes the next. So obesity precedes diabetes, and diabetes precedes heart disease. Going back to moderation, we can see that there is a significant interaction between X9, which is obesity, and M11, which is our moderator of gender. We can then plot this data, and we can see that when our moderator is factored in, the relationship between heart disease and obesity is disrupted. And we can see this by the direction of the data in this graph. We can now conduct diagnostics, and nothing out of the ordinary appears here. There's no heteroscedasticity visible, and there's no curvilinearity in this plot. So all of this combined tells us that our moderator does have a significant impact on the directional relationship. We can then continue on to mediation, and for mediation we're going to use a couple of different methods. First, we'll start off with the Barron and Kenny method from the optional readings. So first we're going to examine the relationship between X and Y, and here we find a significant relationship. We're then going to create paths A, B, and C for this method, and for path A we're looking at the effect of X on M, our mediator, and we find that our relationship here is significant. Continuing on to path B, we're going to look at the effect of M on Y, and we find another significant relationship here. Next, for path C, we're going to be looking at the effects of Y on X, and we're going to control for our mediator M, and once again we find a significant relationship. Finally, we can conduct a Sobel test, and we can see here that our p-value is not significant at the 0.05 level. And this graph over here gives us a more detailed representation of our model for the Sobel test. However, the Sobel test is a more conservative estimation, and when we do a more modern method for mediation and we run our model with the mediate package and we conduct bootstrapping, we find this output, and we can see that our average causal mediation effect, ACME, is significant at 0.014, and this is represented in the graph. So this tells us that our mediation effect is in fact significant. And while this is all I have for this presentation, there was one thing I wanted to discuss further. I did conduct diagnostic plots for mediation, and they gave concerning outputs, and so I conducted some bivariate scatter plots on the data, and it did tell me that there may have been a binary variable in the data which was causing the diagnostics to look so peculiar. However, I did not feel like I could talk about this very in depth, and so I did not include these slides in the presentation. And so that is all I have for this module. Thank you for watching.